In a way, what you just saw is machine learning, but honestly, the more you learn about it, the more you realize what kind of intricacies are going on behind the scenes. And how do you learn those intricacies? Well, that's what I'm here to talk about today, to go beyond what the memes joke about and to discuss what helped me in my introductory ML journey. Hello everybody and welcome to the channel. If you're new here, my name is Mark and I'm a computer science and language and mind student studying at NYU, graduating in the winter of 2021. Back in spring of 2019, I was studying in Paris and one of the classes I was taking was machine learning. And despite the interruption that was the Backstreet Boys tour, I was able to learn quite a bit in my introduction to machine learning course. This video is intended for people who want to take their first steps into machine learning or, like me, found themselves in a class that they were struggling a lot in and need some outside help. While I don't have much machine learning authority, I'm no machine learning expert, I did struggle a lot and I wanted to share the lessons that I got from those struggles. The aim for today's video is to discuss what worked for me amongst all that difficulty and some things that I learned that I want to share with you guys. So today I will be talking about some non-programming concepts you're going to want to know before you start machine learning, the Python concepts and libraries you will absolutely need under your belt, resources that you're going to want to become real good friends with, and some really great ways to apply what you practice as you learn. If you want to skip to any point in this video, the timestamps are in the description down below and the video bar will have little sections sectioned off as a result. But without further ado, let's get right into it. Speaking of prerequisites, it's quite easy to just kind of jump into machine learning and write some code without knowing what's really happening underneath. But if you want to get far into it, you want to do it with less frustration, you want to have a deeper understanding, then learning what machine learning is really doing, what the code you're writing is doing, how it's analyzing data, you're going to want to have at least a beginner level idea of these concepts, if not an intermediate one. Again, you could go right into the coding without knowing any of these concepts, but it's going to lead to a lot more frustration and you're not going to fully understand what you're doing. At least you'll be learning it in a very, very specific scope. I got past the probability and statistics requirement that I was required to have for the class, and I took linear algebra at the same time, and I definitely wish I had taken them beforehand. How I see it, programming in machine learning is a tool to represent this probability and statistics of various data sets. In other words, code is the tool of machine learning, whereas the sustenance, the body, the nutrients are probability and statistics and calculus. Code is simply a way to parse the data and then present it in a way that we as humans can further analyze. When it comes to multivariate calculus, you don't need to know everything about it. For Intro to ML, we didn't need to know integrals or anything like that, but derivatives and partial derivatives and representations of 3D space and some pretty basic calculus came in very, very handy. You could copy formulas off the web, but you're not going to have a deep understanding of what you're doing. Statistics is incredibly useful, if not a necessity, behind machine learning. You could run a multi-class classifier that you find online, but if you want to make modifications to the Gaussian distribution or whatever formulas are being used, you're going to want to have an understanding of statistics. When we got to some pretty advanced concepts like manifold learning, I needed to go into a statistics textbook, read the chapters on that so I had a broader perspective of what this all meant within the field of statistics so that I could actually make my own solutions to the homeworks we were given. Again, you don't need to be a pro at statistics, just have a general understanding of how it might work as well as probability, because machine learning really is just statistics. Next is not a math thing, but a psychology thing, classical and operant conditioning. This concept really helped me understand reinforcement learning, like Q-learning tables, and other reward-based algorithms. Like me walking into a door and learning what works and what doesn't is pretty helpful to just conceptualize the code you're writing when it comes to these kinds of reinforcement learning algorithms. Linear algebra. If you really wanted to, you could get by without knowing how to do derivatives and partial derivatives. You really can't get by without some statistics knowledge, and the further you go in, the more you're going to realize you need statistics, but you pretty much can't do anything without knowing linear algebra. And if you don't know what vectors are or how matrices multiply, and more specifically, when you're using a library like NumPy and you don't know how matrices multiply or how vectors can work and what translations are, what inverses are, you're going to have a really rough time writing some code. When we're dealing with data, we are often working with n dimensions where n is like 10,000, 100,000. Since we can't conceptualize this, having a basic understanding of linear algebra to represent these dimensional systems, vectors, planes, matrices, is really crucial if you want to derive your own solutions. Again, you could copy the equations, but if you don't know what to edit and you don't know what to modify, you might find yourself totally lost, and even worse, you might write something really inefficient. If you're someone who knows more about these concepts, perhaps agrees with me, disagrees with me, or you have other subjects and topics that you think people should know coming into ML, definitely leave a comment down below because, again, I'm not the best machine learning person out there. This is just after a week or two of this class, I was like, oh, I wish I didn't bypass those those prerequisites. That being said, if you can do the math, you're in a really good spot. One way I want to analogize this is with drawing. You can pick up a pencil and you can draw whatever you want. And hey, you might get really good results. But for people with understanding of perspective, lighting, form, maybe even color theory, if you're putting color into this, they'll be a little better off when they start drawing. Having an idea of how these things works makes the practice process and the analysis process of your own work much more smooth. My professor had his degree in theoretical mathematics, I believe, or applied mathematics, something like that. And he explained the math really well. I did not fully understand it, but I could tell that he was explaining it very thoroughly. If you're learning linear algebra and statistics and probability, and you apply those to machine learning, you're gonna be a little better off. You can jump into art without knowing any of those three things. You can jump into coding a machine learning algorithm without knowing any math. It's just going to be a rough process. So that being said, if you do know the math, you are definitely going to need to know how to code. And whether or not you're jumping into programming for the first time or you're super experienced in C or something like that, Python is definitely my #1 recommendation for machine learning. I'll get to this in a minute, but Andrew Ng's Coursera course uses Octave. Some people use R. I just think Python is super widely supported, and that's what I'm going to be talking about in this video. That's what we used in class. So I have never really taken a deep dive into Python aside from really short scripts. I genuinely didn't know how functions work. I wouldn't know how to make an object-oriented program in Python. I watched this video by Banas, link in the description, of course, because as someone coming from Java or C, I don't need to relearn how to program. Well, I don't think I do. And I just wanted to know the Python syntax, how this array structure stuff worked. And that's exactly what this video did. He doesn't explain how functions work exactly or how if-else statements work, at least not in depth, but if you're coming from another language and just want to know the ins and outs of the Python syntax, it's a fantastic video. And he has a video like that for several other programming languages. Again, he doesn't go in depth on how to program exactly. So if you're new to programming, definitely look into programming specific courses, but there's a reason why the video has millions of views. So there's a description in the description. Also, there's a link in the description below to elitedatascience.com, and they have a really good getting started with machine learning intro guide and have a ton of resources on there that is kind of a more cohesive way to put together this video. I'm speaking from experience, that's a bit of a more objective list. Lastly, in terms of what you should know before you jump into things is to know the documentation of the resources you'll be using. At the start of my semester, I spent a few collective hours going through NumPy, Scikit Learn, and Pandas documentation. All three of them have fantastically documented and well-written, cohesive quick start guides. I would recommend going to the documentation if you ever have any questions on these things, but definitely do the quick start guide. My class was mostly theory because in theory, we all knew how to program. Thing is, most of us have never used NumPy or Scikit Learn. My professor kind of assumed we did or would be able to figure out pretty quickly. Going through the quick start guide, it took maybe 2 hours, I believe, and actually do each part of the quick start guides because seriously, it's super helpful. But for NumPy, it took about 1.5 hours to 2 hours-ish, I believe. It was really clear and incredibly helpful. And again, you have to apply what you learn. You are cheating yourself if you don't try to apply it. Mix up the numbers, see how things work, what executes, what's the output. It's a great way to see how vector math and matrix math works. If you don't know the pure basics of the tools you are using, you might get very frustrated, or even worse, you might come up with a very inefficient solution. Quick example, if you're trying to make a vector out of a Python array, you don't want to do that. You want to use NumPy arrays. NumPy is a fantastic library, and I'm not going to explain how it works because you should read their documentation, at least their quick start guide, but it's incredibly powerful for computations. Pandas, as I mentioned earlier, is a library that's incredibly powerful for data frames, and Scikit-Learn has a bunch of useful algorithms that you can use. But again, you gotta go through these quick start guides, see how they work. It's not just teaching you the library, but it also gives you a little bit of insight into how machine learning works, what the math is under the hood. And getting comfortable with Python, and specifically these 3 libraries, probably a few others like matplotlib, are crucial because you will be using them a lot throughout your machine learning journey. The time you put into the basics now will make the rest easier. You gotta build a foundation to build on it. Also, if there are any libraries you've heard about, drop a comment. I'd love to hear it. So, once I finished those quick start guides, the last thing I needed to do was to sit down and do the homeworks and assignments. Now, all the resources I have talked about up until this point and throughout the rest of the video will, of course, be in the description below in the resources section, except for the things that I don't have permission to distribute, like textbooks or something. I mean, how unfortunate would it be if you use one of those nasty sites like Library Genesis that gave you textbooks for free and you wouldn't have to spend, free education. You get the point. That was kind of cringy. So with NumPy, Scikit Learn, and Pandas bookmarked, I had a few other resources by my side. One of the things I had was a statistics textbook on me because I would go to some of the sections and it would help me get a bigger understanding of something we were doing in machine learning class. It would give me this thing's place in the world of statistics versus its direct relevance to machine learning. I found this neural network book through 3 Blue 1 Browns videos. Definitely check those out, by the way, on neural networks, and that's totally free and available online. I would recommend donating if you can and got use out of it. Now, I hope it's obvious that I didn't sit down and read these entire books. They were very clear. They provided code samples. Well, the statistics textbook didn't, but you know what I mean. All in all, my professor gave us a lot of equations and examples of things that were very specific to machine learning, and me personally, I thought it was incredibly useful to understand where these things were placed in the greater scheme of things. Granted, I didn't take a statistics or probability class prior to that, at least not one for mathematics. I took a statistics for psychology, but that's a whole separate thing. So having that basic foundational knowledge was amazingly helpful for me later on. Saved a lot of frustration, I'm sure. Next is the Wombo combo, that is machine learning on Coursera by Andrew Ng and John Wittenauer's Python version of those exercises on his website. The Coursera course is fully free online, and Andrew Ng's explanations are amazing. Coursera also gives you a curriculum, and unless you're going for the certificate, you can do it at your own pace, so you can spend 4 weeks on the first week's topic or something. The videos seem low quality, but his explanations are impeccable, and they still stand today. Thing is, they ask you to use Octave, which I've never heard of it outside of that context. If you want the certificate, go ahead and use Octave. I don't think that's a bad idea. But if you're like me and you're doing this for a class that's using Python, or you're working on your own project and you want to learn things in Python, I would recommend doing the challenges Andrew Ng sets up and do them in Python. Take his data sets and work with them in Python. Using NumPy and Pandas, you can do the same thing. And this is where John Wittenauer's site comes up. I don't remember exactly how I found it, but he has all of Andrew Ng's exercises done in Python, and the explanations are amazing. So my homework assignments were really confusing, but I would work through these concepts on Andrew Ng's Coursera page and then work on the exercises in Python alongside John Wittenauer's page, and they helped clear a lot of things up. And lastly, Medium articles. No links for these because there are just so many out there, but it's really valuable getting like 3 or 4 people's perspectives on what's important about a certain topic, or reading through like 4 or 5 people's different explanations of a topic, because you see what matters when one thing is present in all of them. And lastly, in terms of IDE, which is Integrated Development Environment, you can really use whatever you'd like. If you're new to programming and new to Python, I'd recommend Jupyter Notebook. You can run segment by segment, and it's a super great IDE to use. Otherwise, I'd recommend PyCharm. I really love JetBrains' products and stuff. Anyway, you have all of these things by your side and you're ready to get going. You started off reading a little bit. You've done a little bit of exercises on Wittenauer's websites on the exercises. You've read a little bit about neural networks. You've looked at the code. Your mind is totally boggled. You want to jump into your own project, or you just want to find something fun to work on. And thus comes the application section of this video. I'm a very big proponent of applying what you learn. If we don't apply what we learn, we don't consolidate it. And as a result, we don't really learn it. For example, if you're doing the NumPy or Pandas Quick Start Guide and you don't do it alongside it, you're not fully applying what you're just reading. When you apply these things, you find out what you really don't know. Even if you think you have a full grasp on it, do it anyway. What's the worst that can happen? The final project for my machine learning class was largely up to what we wanted to do. Now, I was originally going to do something with natural language processing and go lone wolf, but a friend I had made in the class wanted to do the project together, and I was like, all right, yeah, why not? And we ended up doing an analysis on PUBG data. And I just want to make a quick digression. My partner's really carried his weight on this one. So amongst all the trouble that I had in that class, the group project did not contribute to that and really helped it end on a strong note. Anyway, what we did in the end was an analysis on PUBG data. There's a website called Kaggle, which is a fantastic website. Again, not sponsored. I don't know why you would think this would be sponsored, where you can find competitions and, more importantly, data sets to practice your skills. They have these very well written out guides on how to solve things. And the most important thing here is that as you work through these guides, and amongst all of the custom notebooks and tutorials that people have written on Kaggle, you learn by doing. That is just, you can learn everything by doing. If you take anything away from this video, learn the math, then go straight to Kaggle. It's aesthetic, it has a community, and it has Jupyter notebooks that you can run on the website itself. Maybe you're a little further in your ML exploration and want more practical data sets, such as auditory experiments or medicinal research data sets. Check out the UCI ML Repository. Again, all links are in the description down below. Anyway, data can be scary to look at. So whether you're on Kaggle or you're getting it from the UCI repository, you definitely want to know Pandas to make things more visually comprehensible. Kaggle and John Wittenauer's website use NumPy and Pandas extensively. So you can learn these things by going through his tutorials and seeing what they do. It's really important that you can have at least a visual grasp on your data. Performing a simple linear regression or multivariate classification can just show you what you're working with. And again, with Kaggle, you have a specific direction to go to, so it's a great website. In our analysis on PUBG, we use things like linear regression to see general trends in data. What gameplay had the biggest impact, the biggest influence on someone winning? We did some classification on teams and solo games, although we ended up scrapping the team thing to focus more on the solo games. Now, the dataset came from Kaggle, and while we didn't do what the Kaggle thing asked us to do, we didn't use kernels or anything, we just had fun with it. We messed around with what we learned in class, and we got some pretty cool results, some pretty cool graphs to look at to then get trends from. You feed the computer numbers, you get graphs, and then as a human you say, oh, look at that. There is an incredibly strong positive correlation with the distance people walk and how many times they win. So if you're playing PUBG, move as much as possible. Now, I've spoken about a lot of things in this video, so I hope you got something from it, and if you did, leave a comment down below. I'd love to hear it, because again, I'm no expert. This video was just to maybe help you get your feet wet, to dive into your curiosity. If you want to jump straight into math and understanding the concepts that I've been throwing around, like linear classifications, gradient descent, manifold learning thing, I would definitely recommend going to 3 Blue 1 Brown's videos and looking at those. If you're looking for statistics concepts, visit StatQuest. Those videos saved me. The quality seems off at first, but the explanations are so clear, there's great visuals, there's very entertaining intros on every single video. Again, you can always jump straight into Kaggle and learning on the tutorials that they have on there, but knowing what's going on in statistics and the math behind it all is never a bad thing. Alas, thanks yet again for watching. Maybe come back in a few weeks, share with me what you've learned, if any of these things helped specifically, or if any of them didn't. This is sort of what worked for me. These are the things that I think made the biggest difference in me actually understanding at least a semblance of what was happening in my class. So once you have all these ideas in your head, clarify what your goals are. Write down what you're gonna do next. Make a list. Get out there and get it done. Curiosity is fantastic. It's necessary, but if you don't get out there, if you don't start acting on your curiosity, you're never gonna find any answers. So let me know what your thoughts are down below in the comments. Let me know what you want to see from me next. And if you're curious about more videos from me, you can see some videos and playlists on the screen now, along with the subscribe button. And lastly, my upload schedule has changed to every Monday at 10 a.m. because it's very nice to have the entire weekend to work on these videos. So until then, stay tuned. Thanks again for watching. Have a good one. And as always, don't forget to stay awesome.